So we have some time to digest the world and then make our own experiments. Anyway, so this is kind of my philosophy, but how do we fix that? How do we become better thinkers, better questioners of the world and reality? We have to start asking questions. What kind of questions do we ask? The fundamental ones. Why, how, and what can we do about it? That's really the most important thing. What can we do with the knowledge that we have? Knowledge is power, right? So where do we start? Let's start over here. So we can start by asking, how is aspirin effective, or yeah, and how effective is it? And what are the kinetics of that reaction? How long does it take to degrade? These are important questions. If you're going into pharmacy, if you're the person taking the drug, you need to know how fast it's degraded and how much you should be taking. So I have a reaction here, which is so relevant. This is aspirin. I don't have aspirin in my house, which I took a leave, which is a completely different chemical, but I'm just using it as a prop here. This fake aspirin here will break down into two compounds you should recognize maybe. Salicylic acid is really commonly used in dermatology. I have my salicylic acid here. It's good for exfoliation of the face, of skin. It's also used for warts. That will break down, and then also you'll have some acetic acid, so you're gonna have some vinegar that comes out of that. And these are things you can recognize because of this class. You learned how to recognize these molecules, and you're gonna be learning about the kinetics. You're starting to learn about the kinetics. This is a first order reaction. And especially with orgo, you're going to learn a little bit more about what that means. You can also study the half-life, which is important for your dose and how often you should take it. Let's see, what are the questions? You can ask about how dynamite works. It contains this chemical called nitroglycerin. It's very unstable and it explodes very easily. But why? What makes certain things unstable and certain things not? You learned about it, you know how. This reaction is very spontaneous. It has a very great negative delta G, right? It's very exothermic, plus it has a large entropic change. It has a large entropic, it increases the entropy. So if you want to look on this on an energy scale, you can see it has a very, it's very thermodynamically favorable, okay? So you can start to think about reactions that way. Okay. What else? How do batteries work? You learned about that. It basically overall generally is you're converting chemical potential energy to voltage, to electricity, right? And then the more important question is, why do we care? What can we do with this information? That's ultimately our reason for learning things, is using that knowledge, right? So what can we do with it? So, or why can we do it? Then we can ask ourselves what we can do it. So why can we do this? And you learned about redox reactions. We can oxidize fuel for energy, right? So in glucose, for example, is fuel, just like the fuel in your car. You oxidize it, you remove those electrons for energy. And one important thing before I go on to talking about how we can use the knowledge of batteries is an important question here, and I'll go back to my previous notes up there. But first I want to talk about this quote by Henry Ford, and then I want to talk about how this relates to Elon Musk's philosophy as well. So this is amazing. So he said, Henry Ford, he's like, if I had asked people what they wanted, they would have said just said faster horses. Okay, and look where we are now. What do we have? We have something so revolutionarily different than horses, and this kind of thinking was necessary. And Elon Musk, if you watched interviews with him, he emphasizes kind of breaking down things to their fundamental components. Why do batteries work? And how can we how can we use that knowledge, that basic knowledge, go all the way to the base knowledge and make something better, right? So we were using horses, but something fundamental about using horses for transportation must have inspired something else, the use of combustion and things like that. So if we go to this question, how can we use the knowledge of batteries to improve the world? We can revolutionize battery life. We can change the way batteries even work. I don't know how, but maybe you will. You can do things from helping missions to space, helping space travel, to improving day-to-day transportation of everybody. Another thing that is kind of out of the box is using methanogens. So these are microorganisms that that metabolize methane. And if you know anything about methane right here, you know it doesn't really hold that much energy at all. It's like a product rather than a reactant you want to be using for metabolism. It's not something with a lot of energy. It's like the waste, right? So, but these organisms found a way. Okay, they use the basic knowledge of redox, the basic knowledge of metabolism, and found their own pathway. And that's what we need. That's how we need to restructure our brain, is taking our base knowledge and then going a completely different direction with it. Okay, what else? Okay, so we can also talk in terms of health. pH is so important in health. Acid base is so important in biology, especially. So one question is, how does dysbiosis in the vaginal microbiome lead to more infections? So what do I mean by dysbiosis? It's kind of a disruption in the natural microbiome, in your natural flora in the vaginal region. So the answer to that is women have really important types of bacteria, the subspecies of lactobacillus, which keeps the pH pretty low at around 4 pH. So it does this through lactic acid production. You've probably heard of lactic acid fermentation. Our muscles do it. That's why we get sore. It's kind of like an anaerobic respiration, right? And this acidic pH keeps foreign invaders out. They basically can't handle this pretty low pH, right? It's pretty low. And then we can ask ourselves, what can women do to improve their vaginal health? How do they maintain it? Things like that. They have real repercussions, but pH is so important in literally every biological function. It's basically the foundation of biochemistry. So redox and pH and acid-base chemistry is the foundation for biochemistry. So if I'm taking biochemistry right now, if you'll take it, this information is the foundation for all of it. Okay, so I have an experiment here, and I have it, I have the reaction covered up, and we'll talk about it. Okay, so I took, so if you've heard of like litmus paper, I have some tests that I've done with like litmus paper before. They're basically, it's just like the different colors. It shows you, it's like a pH indicator. I just did it with different types of water, like tap water, deionized water, distilled deionized water, and they gave me drastically different results. Anyway, today we're going to be doing it with an acid base, pretty simple. It's probably like some experiment you do in like middle school, but I had the resources and I'm doing it. So I had this litmus powder here, which I got as a gift. Like I got this science kit it's like a tiny one as a gift. Anyway, so I put some sodium bicarbonate, which is just baking soda. And I put some citric acid. So I have my sodium bicarbonate, or you can just get just baking soda, and then citric acid in powder form, which you can just get with like lemon juice. And And I have them in these two. I should be wearing my gloves. I'm not dealing with anything dangerous, but I have them in these test tubes here, and we're going to see what color they turn into. Once I've used the indicator, I have some water. I don't have distilled water, just filtered water, but we're going to run with it. Okay. And I dissolved it before class started, so hopefully it's better dissolved. Okay. And you're going to see what color. I shouldn't be doing this over my computer, but whatever. Okay, so here's the citric acid, not completely dissolved, but that's okay. You're going to see what color it changes into. Red. Wow. Okay, very nice, right? Okay, and for your question of the day, the two chem labs, I've worked in labs, okay, for like, I don't know, maybe 3 years now. And I've never been in a situation like more strict than the chem labs. Let me tell you, my first semester, my first lab in all of college, I got kicked out. And I had to go I had to climb mountains to make sure I was wearing the right PPE. I was wearing sandals, and so I had to borrow this random guy's soccer shoes. I know there's a story in the news where like one girl had to switch pants with this random guy because, you know, it wasn't covering the ankles. It's ridiculous. But when you go into like real labs, they're never that strict. Don't worry. Anyway, okay. So the acid turned red. Okay, the citric acid. I want you guys in the chat to write what color you think the base is going to be. That'll be your question of the day. Okay. First, I'm going to do some water. This is just water. It's kind of dark. I added a lot, but let's see. It's kind of purple, maybe. That's what I would say. Okay, so here is, actually, let me dissolve this more. So bonus question, why do acids and bases dissolve in water? Why do they dissolve in water? What do you guys think? Not everything dissolves in water, right? So here's the base. Okay, I shouldn't have spread it that much, but yeah, it should be kind of bluish. It's more purplish, I don't know, but it should be bluish. Yeah, it's more purple, to be honest, but what are you gonna do? Nothing's perfect. Okay. Anyway, so the acid and base dissolve in water. Citric acid dissolves, the base dissolves, and it's because they're polar, okay? They have a bunch of oxygens in there, because, yeah, exactly. No, I mean, water feels nice to dissolve in. Water is attracted to and forms hydrogen bonds with polar groups, polar just meaning electronegative or positive ends, right? Anyway, so those are our two, acid and base, but we're not done yet. The fun part is coming. So I want you guys to predict what would happen if I combined the acid and base together. Purple. I wouldn't show you if it was just mixing colors. It's more exciting than that. So I don't know, should I show you the reaction first? I'll show you the reaction first and get you guys thinking a little bit. Oh, I probably should have like stopped recording, stopped the whatever screen this is, my iPad screen. Anyway, okay, so this is the reaction we're going to be working with here. So we have sodium bicarbonate here, okay? We have our citric acid, and this is what it's going to form, okay? So I want you guys to predict, what does this mean? What does this mean here? What is it going to do? Maybe some foreshadowing. Okay, I'm going to stop recording that screen so you can see me nice and clear. Soda, yeah, yummy soda. Okay, why isn't the screen on me? Okay, I did this in my brother's room yesterday. He was not that happy. Okay, are you ready? Just a little anticlimactic, but oh shit. See, you get it everywhere. I have a container here, so I tried to capture the reaction. Exactly, carbon dioxide emissions, yes, specifically carbon dioxide. And it's still reacting, it's still bubbling. I don't know if you can hear it. Can you hear that? Anyway, so I'm not done yet. That was the end of the experiment part, but I still have a little bit more to talk about here. It's still reacting here. Yeah, I did this in my brother's room yesterday. He got all over the floor. Reaction ASMR for sure. Okay, let me get back. Okay, and then my question, hold on. My question to you, which is a really important question, is have we almost figured everything out? What do you guys think? With this acceleration of scientific discovery, what do you guys think? Are we almost done? Are we almost done? Are we halfway done with science? How far are we? Not even fathomably close, right? Not even fathomably, 0% basically, right? Not even the tip. It's like the what is it called? A snowflake on top of the iceberg. That is what we figured out so far. Okay, so I just want to end with my favorite quote of all time. I heard this quote about 6 years ago, and it was like the turning point of my science career when I was in high school. It says, "Nothing is so fatal to the human mind than to presume that our views of science are ultimate, that there are no new mysteries in nature, and that our triumphs are complete, and that there are no new worlds to conquer." Okay, so I will leave you with that. Make sure you said something in the chat for attendance. But yeah, so you guys are good to go. I hope this made you think a little bit. and I will see you next time.